Have you ever stopped to think about how your computer, your phone, your TV, and even your printer all manage to talk to each other? It kind of feels like magic, right? Well, underneath it all, there's a secret map, a blueprint that lays out exactly how everything is connected. That blueprint is called a network topology, and today, we're going to pull back the curtain and see what it looks like.
So, here's what we're going to cover. First, we'll nail down what a network topology actually is. Then we'll dive into the most common layouts. You've definitely used these without even realizing it. After that, we'll check out some more advanced, heavy-duty designs, unpack the tricky difference between a network's physical and logical shape, and finally, we'll talk about how you choose the right fit for the job. All right, let's start at the beginning. What exactly is a network topology? Let's get right down to the fundamental definition.
At its heart, a topology is simply the layout for a local area network, or what we call a LAN. It's not about the gadgets themselves, the computers or the printers. It's all about the pattern, the architectural plan that shows how everything is linked together.
Okay, now that we've got that down, let's get to the fun part, exploring the actual designs. These are the classic, foundational ways that most networks are put together.
We're going to kick things off with the one you've absolutely run into, probably in your own home. It's called the star topology, and there's a very good reason it's become the go-to for most home and office networks today.
And here you can see its biggest trade-off. In a star setup, every single device connects to a central point, usually your Wi-Fi router. This makes it super easy to add a new device. You just connect it to the router. But the flip side? That router is a single point of failure. If it goes down, everything, and I mean everything, connected to it goes down too.
All right, next up, let's take a little trip back in time to an older but really important design, the bus topology. The name is perfect. Just imagine all your devices are like bus stops on a single long road, and all the data travels up and down that one main street. Now, the appeal here was pretty obvious. It was really cheap and simple to set up. You just ran one long cable, the backbone, and plugged everything into it. But the downsides were huge. All the devices had to share that one slow lane. And even worse, if there was a single break anywhere in that main cable, the whole network was toast. Okay, so moving on from a straight line, let's talk about connecting everything in a circle. In a ring topology, every device is connected to two others, forming a continuous loop. Data just travels around and around from one machine to the next.
The big advantage here was all about control and order. It used a clever system where a digital token was passed around the circle, and only the device holding the token could send data. This prevented data collisions, which was great, but, and you're probably sensing a pattern here, it had that same critical weakness. If any one device or cable in that loop failed, the whole circle was broken.
So as you can probably tell, all those simpler layouts had some pretty obvious weak spots. That, of course, led engineers to get creative and develop more complex, more resilient designs with one big goal in mind: build networks that just don't fail. And that brings us to the king of reliability, the ultimate in network resilience, the mesh topology. The whole philosophy here is simple. Why have just one path for data when you could have dozens? Think about it. In a full mesh network, every single device is connected directly to every other device. So if one connection goes down, who cares? The data just takes another route. This makes it incredibly fault-tolerant, which is why the backbone of the internet itself is a mesh. But the trade-off is massive. It is wildly expensive and incredibly complex to set up and manage. But of course, you don't have to be a purist. In the real world, network designers are always mixing and matching. A tree topology, for example, is like connecting a bunch of smaller star networks onto a main bus line, kind of like branches on a tree. And a hybrid topology is just what it sounds like. Any custom blend of layouts designed to get the best of all worlds. And then you have this simplest of all, a point-to-point link, which is just a direct cable between two devices.
Okay, this next part is super important. It's the concept that really separates how a network looks on paper from how it actually behaves in the real world. We're talking about the difference between a physical and a logical topology.
So here's the deal. The physical topology is the literal wiring, how the cables are physically run through the walls and plugged into devices. It's what you can see and touch. The logical topology, though, is the path the data thinks it's taking. So for example, you could have a network that is physically wired up in a star shape, but it's programmed to pass data around like it's a ring. The big takeaway here, how it looks isn't always how it works. So after all that, star, bus, ring, mesh, hybrid, how in the world does anyone actually choose the right one? Well, like with pretty much any big engineering decision, it all comes down to a balancing act. It's all about the trade-offs. And this really lays it all out, doesn't it? If you just need something that's easy to manage and troubleshoot, Star is your best friend, but you're accepting that single point of failure. If you're on a shoestring budget, Bus is cheap, but you're stuck with a slow and fragile network. And if you absolutely positively cannot have your network go down, Mesh is the answer, but you'd better be ready for the huge cost and complexity that comes with it.
So at the end of the day, there is no magic bullet here. There's no such thing as the one best topology. The right choice is always a puzzle you have to solve, and the solution depends on the network's specific needs. What's the budget? What's its purpose? And maybe most importantly, how bad would it be if it ever went offline?
And all this leaves us with a pretty fascinating question to chew on. We've watched these designs evolve from simple, brittle lines to incredibly complex, self-healing webs. But as our world gets even more connected, with everything from our smart homes to our cars coming online, what will the next hidden map of our world actually need to look like?